So this is going to be our homework help video for solving inverse trig representing multiple solutions. We'll go ahead and get started here with problem number one. Problem number one, we've got square root of 2 over 2 equals cosine theta. First step to isolate theta, we take the inverse cosine of both sides. So that's just a cosine with that little -1. And now we start kind of our multi-step procedure to figure out what the inverse cosine of this number is. The first step of that procedure is to identify if this number here is positive or negative. It's clearly positive. So that gives us some information about where the angles that lead to this ratio are within our coordinate plane. So we can create this diagram here. All students take calc. I know that I'm looking for when cosine is positive. So that's going to happen in the all quadrant where all of them are positive, and in the cosine quadrant where just cosine is positive. All right, next thing I do after having figured that out is I remind myself what ratio does cosine give us, and therefore it's the ratio that we're taking the inverse cosine of. That's always adjacent over hypotenuse. I line that up with that fraction there. I can see that the adjacent is the square root of 2 and the hypotenuse is 2. So into these quadrants, I want to draw triangles with an adjacent length of square root of 2 and a hypotenuse of 2. Do my best of that now. Let's see, those side lengths clearly come from a 45, 45, 90 triangle, so I'm going to do my best to draw a 45, 45, 90 triangle going into these quadrants. So that adjacent length there is the square root of 2, and the hypotenuse is 2. These are 40. This is the side lengths of a 45, 45, 90. I could fill in that last side length if it would kind of help complete the picture there. So the interior angle is 45 here. The interior angle is 45 right down here, meaning that these terminal sides land at 45, and what is this, 315? Yep, you can figure that out. You could go 360 and then just back up 45. Let's change those into radians real quick. 45 degrees is the same as pi over 4 radians. 315 is the same as 7 pi over 4. And to both of those answers, we must append plus 2 pi n. The reason we do this is that this terminal side here gives us the right ratio, and we can get to it by going 7 pi over 4, but we could also then, once we're on that terminal side, make another full revolution, end up right there. So that plus 2 pi n allows us to make full revolutions and still end up on that correct terminal side, giving us the correct ratio for our inverse cosine. Somewhere on your paper, probably just up near the top, you can write that n is an element of the integers, and then that'll just count for the whole paper. All right. On to another one. This tangent one, it's a little bit interesting. Inverse tangent of both sides, obviously, to isolate the variable. Now we got theta equals inverse tangent of 1. Same procedure to go through this one. We recognize that this is a positive number. We could do our all students take calc diagram. All students take calc. Ask ourselves, when is tangent positive? And that's going to happen when they're all positive, and over here when tangent is positive. All right, tangent is the ratio opposite over adjacent. How can I make that equal to 1? Well, I could make it 1 over 1, or I could make it -1 over -1. Both of those would then still give me 1. Let's fill out our triangles, give them the correct side lengths. So triangle here with an opposite of length 1 and adjacent of length 1. This is a 45-degree angle in here because these are the lengths of a special triangle, the 1, 1, square root of 2. 45, 45, 90 special triangle. Down here, I fill in another triangle. This one, I'm going to give it lengths -1 and -1, but notice opposite over adjacent still gives me 1. That's why this is another valid angle. So another 45, 45, 90. To get to that terminal side, I could go 180 plus 45. That gets me 225. Now, the thing about these two angles is that they're exactly 180 degrees apart, so we can just use the shortcut. The shortcut is we just write only the first angle, then we say plus 180 degrees n, and then that way we can then get our second angle. And then we add another 180. We go back to this terminal side again, another co-terminal side here, add another 180. We're back over here. So this here will give us all of the correct answers. The homework does ask for a radian, so I'm going to switch this to pi over 4 plus pi n. And we're covered on what n is by what we wrote at the top of our paper. All right, let's try one of these where we've got an operation on the outside that we have to solve. I could do this by just adding 1 to both sides. Now I've got sine of theta equals 1/2. I do the inverse sine of both sides. I've got theta equals inverse sine of 1/2. Let's remind ourselves that's an opposite and a hypotenuse. Sine is positive in these top two quadrants. So we're going to need to put triangles where the opposite is 1 and the hypotenuse is 2. You're going to look kind of like that and that. 1, 2, 2, 1. This is a 30, 60, 90, where that angle in there is the 30. That angle in there is another 30. And to get to our terminal sides, we could go 30, or we could go 180 and back up 30. That's going to be 150. In terms of radians, we get the answer for number 5 as, I'll write it here, pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. All right, on to some more challenging ones. 7 and 8 are both pretty darn challenging. I'll start with number 7. Here, my goal is just to isolate theta. So I need to get all the operations that aren't part of theta away from theta. What I can do is I can just cross out this 3 from both sides, and then divide both sides by a -4 to get rid of that coefficient of -4. And you'll see they both have a -4, so we can cancel that out as well. Now what do we have? We got secant of 3 theta plus pi over 4 equals the square root of 2. Now we have to take inverse secant of both sides. All right, so maybe space with some more room, we're going to figure out what the inverse secant of the square root of 2 is. Why don't I turn that into the square root of 2 over 1 so that I've got a fraction. Secant is the reciprocal of cosine, so it's going to follow cosine with where it is positive. So we can create our all students take calc diagram. Go ahead and highlight where cosine is positive. That's where secant is going to be positive as well. Let's remind ourselves the ratio that secant represents. Secant is hypotenuse over adjacent. So now that as I move towards my diagram, I want to put triangles into these two quadrants where the hypotenuse is the square root of 2 and the adjacent is 1. That should sound familiar as a 45, 45, 90. All right, so the answers to inverse secant of the square root of 2 are pi over 4 and 7 pi over 4 plus 2 pi n. Let's keep going on that. So once I take the inverse secant, what's inside of this is now just by itself. It's going to be 3 theta plus pi over 4. And the inverse secant of square root of 2 is pi over 4 plus 2 pi n. And let's write the whole thing again, 3 theta plus pi over 4 equals this time 7 pi over 4 plus 2 pi n. So you have to have two separate equations for these two different angles. Now we're still just solving for theta. So I might, in this one, get rid of the pi over 4 on both sides and then divide both sides by 3 to get that theta equals 2 pi n over 3. That's only half of our solution though. And over here in this one, I can subtract a pi over 4 from both sides. I got 3 pi equals 6 pi over 4, which I'll abbreviate to 3 pi over 2, plus 2 pi n. Divide both sides by 3, divide by 3, divide by 3. Copy dot flop, this 3 would go onto the bottom and cancel out with that 3. And so now I've got theta equals pi plus 2 pi n over 3. And that is our full solution for number 7. I think I'll leave it there. You can try number 8 on your own. But best of luck. That's the end of this video.